Okay, there are some other names we give to this. Some books may say trigonometric form, although I don't recommend that. Okay, you either say polar form. Sometimes in past year exams, past year A-level exams, they will have also used the term modulus argument form. Okay, so just to take note, modulus argument form also means the same as polar form. All right, okay. Okay, can you try this very quickly? Let's try this now. Example 6.1.1. Solution. Okay, solution not given. Not given in full. Can you try this now? Okay, I'll give you only 1 minute. 1 minute. Because this one should not be very hard. Okay, have you done for the first part? Actually, the first part is just reading. Reading and writing. Copying and pasting. Because part 1, they gave you the modulus and the argument already. Okay, so part 1, you should have this. Okay, part 2, I don't reveal yet. Part 2 need a bit more steps because you need to work out the modulus and argument yourself. Remember, you want to find the argument, you must draw the Argand diagram. Don't go and apply tangent inverse directly. You will get the answer wrong half the time. Okay, so you should have worked it out. Right, I drew the diagram for you. Okay, just to point out, when you draw this line segment linking the origin to the point representing the complex number, okay, make sure it is a dashed line segment. Okay, that means you should not draw your complex number in this manner, where it's a continuous line segment. Okay, the reason is very simple. What is representing the complex number in this case is the point, not the line segment. Okay, if you draw in the line segment in full, you are indicating that that is the object that is representing the complex number. Okay, which is not true. All right. Okay, so if you worked it out, okay, this is what you should get. Okay. Okay, so let's go on. You actually just need to copy down the polar form, because the polar form will tell you what is the modulus and argument you should get. Okay, so don't need to copy the whole thing. Okay. Okay, next. Okay, Euler's formula. Okay, now I'm going to introduce to you Euler's formula. Okay, this will be on page. Okay, so I'm actually going to skip page 15 for now. We are going to go straight to page 17 first. I'll come back to 15 later, okay, don't worry. Okay, shh. Okay, just now I highlighted to you the Maclaurin series of some functions, right? Okay, so let us take a look. Okay, let us take a look. Okay, this is the Maclaurin series for e to the power of x. Okay, otherwise known as the exponential series. Okay, now, what I'm going to do now is, okay, I'm not going to explain to you why I do this, but I'm going to do this now. Okay, I'm going to replace all the x you see by I theta. I theta. Okay, later on you will see why I'm doing this. Okay, so if I do that, this happens. Don't need to copy, just listen and watch the show. I put a lot of effort into this part. Okay, so I'm very happy to do it now. So please pay attention. Okay, later you see the animation. Okay, now I'm going to apply law of indices. Okay, so in the previous step, you see this, right? I apply law of indices, the powers go inside. Okay, so you'll see this. Alright? Can follow? Okay, now what I'm going to do now is I'm going to evaluate I squared, I cubed, and I to the power of 4, which actually I've discussed with you in one of the earlier lectures. Okay, so what you get is this. Okay, so a bit too fast, right? Okay, previously it's like that. Right, I squared is -1, I cubed is -I to the power of 4 is 1 again. Okay, so you get this. Okay, the exciting part not here yet, okay? Okay, so now, okay, let me just simplify it a bit more. Okay, so I'm going to bring down all the negative signs. Okay, you'll see something like this. Okay, but I pull out the i's, okay, wherever I see the I. Okay, so you see that, for example, the negative theta cubed over 3 factorial, I pull out the I. Okay, why do I do this? Okay, now what I'm going to do is, I'm going to bring down, this is the exciting part. Okay, I'm going to bring down all the parts without the I. So this is real, right? This part is real, right? Okay, now, but this is the Maclaurin series of cosine theta. Are you really excited or are you pretending to be excited? Okay. Okay. If you go back, okay, cosine x is what? This is the Maclaurin series of cosine x. Okay? Then the series for sine x is this one. Okay? Can see that? Okay, so what I'm going to do now is I bring down all the terms without the I. Okay, actually this will give me the Maclaurin series for cosine theta. Hey, don't sleep there, please. Hello? You sleep already, you miss the show. Okay? Then I'm going to bring down all the terms with the I. And what is this? This is, yes, very good. I sine theta. Okay? So, what can we conclude from here? We can conclude that e to the power of I theta is cosine theta plus I sine theta. Okay, so this is, yeah, I spent a lot of time. Okay, anyway. Okay, this is what we call, okay, this is what we call the Euler's formula. Okay, the Euler's formula. Okay, it's a very, very, very important result in complex numbers. Okay? Okay, I don't know whether you are really excited or you were faking it out, but anyway, thanks for accommodating me. Okay? Anyway, okay, so next. Okay, now we have the Euler's formula. Okay, I know that I can re-express any complex number into this new form. right? Because I already showed you that cosine theta plus I sine theta is e to the power of I theta. These two are the same. Okay, so now this gives me a third form. Okay, it's called the exponential form. This is called the exponential form. Okay, so in total, for the purpose of the H2 math syllabus, you must know 3 forms. Okay, the Cartesian form, the polar form, and the exponential form. Okay, very soon you will grow to love the exponential form. Or you'll be forced to love it. Okay, now let's try. Let's look at example 6.1.1 again. Okay, the previous example. Right, these were the solutions. Okay, so let's say now I want to change them to exponential form. Very simple. Okay, this I'll just show you in the interest of time. Okay, all I have to do is I rewrite my polar form, okay, into exponential form. Okay, so the argument goes into the power, the modulus stays on the outside. Okay, so the exponential form of -3 is 3 times e to the power I pi. Okay? Okay, so similarly for part 2, this will be the exponential form of -5 plus 5i. Can? Okay, so you just copy this one. Don't copy everything again, please. Hello. Just copy the exponential forms. Okay? Done? Okay, next. Okay, let's look at example 7.3.1 part 1. Quickly. Those who are done already, go to 7.3.1. Okay, now, parts I and 2, parts 1 and parts 2, part 1 and part 2 already, they write a solution for you. Okay, so it's the same thing as example 6.1.1. Okay, so it's just a reading kind of thing. Alright, okay, next.